So significant figures are a way of telling people what the certainty is in any kind of measurement. And often when we combine different measurements, when we do a calculation, we want to make sure that the answer to the calculation has the right number of significant figures. It also gives the reader some idea of the certainty of the measurement. So we have a couple of rules that we follow in order to get the right number of sig figs. If we're adding or subtracting, so if we're going to add 1.25 to 0.3476. Okay. The best way to think about this is if you line up the decimal place here, there's a decimal there, 0.3476, and just add up in this way, so we get 1.5976. Okay. This is really too many significant figures. It's giving the reader some idea that this is a more certain value than it really is. So how many sig figs do we use? Well, in the first number here, significant figures says that it's all the numbers that are certain plus the first uncertain. So in this measurement, we're saying the 5 is uncertain. That's really kind of a best guess. And if you're adding uncertain to a certain number, your answer is still going to be an uncertain number. So this is saying that we should really cut this off here. So our answer is going to be two decimal places or 3 significant figures. We have to round up. The 7 rounds up the 9, which rounds up the 5 to a 6. So we end up with 1.60 to the right number of sig figs. So the rule for adding or subtracting is that you look for the value which has the least number of decimal places, and your answer should have that same number of decimal places. Now if you're multiplying or dividing, say we're multiplying 1.3 by 0.478. Okay. In this case, well, let's do the calculation first. So let's multiply 1.3 on my calculator by 0.478, and I get an answer of, oops, doesn't look much like a 0, 0.6214. Now, first thing you always want to do is make sure that it looks like a reasonable value, especially when you're using a calculator. Sometimes you can input something and get completely the wrong number. That looks reasonable. So how many sig figs do we use? The rule that we use for multiplying or dividing is that your answer should have the same number of significant figures as the value with the least number of significant figures. So in this case, this number here has 2 significant figures, and this number here has 3 significant figures. Remember again that the 0 is just holding the decimal place. So our answer should have 2 sig figs, which means that we want to cut it off here. So our answer to the right number of significant figures. Now, often in a calculation, it's not just one simple addition or one simple multiplication. We've got multiple steps in a calculation. So let's try an example like that. Let's say we're adding 12.4 to 1.366 and then dividing that number by 3.2. Okay, so how do we figure out the sig figs in this case? Well, if you have a calculation where you do multiple steps, you've got to apply those rules in the same order you do the calculation. The first thing to do is just to do the calculation, ignore the sig figs. In fact, when you're doing a calculation, you want to keep at least enough significant figures so you don't round up and get some called round up error. So let's do the calculation first. We'll add 12.4 to 1.366 and you get an answer of 13.766. So I'm keeping all the sig figs in this case, and then divide that by 3.2. So you get an answer of 4.301875. Now, obviously those numbers are not all significant, but that's what the calculator gives me. So in order to do the calculation, we had to follow it through in steps. So we're going to follow the significant figures rule in the same order. So the first thing we did was add. So we're going to use our rule of the least number of decimal places, so 1 decimal place. So we end up, if we cut this off to 1 decimal place, we have 3 significant figures here. And then divide that by 3.2, that only has 2 significant figures. And since we're dividing, we go with the least number of sig figs. So this should also have 2 significant figures. So our answer should be 4.3.